If you have always tried to get as much details on what's going on in your SQL database, then this episode is for you. This episode is in fact dedicated to one of the technology provided by Google, the SQL Commenter. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Open Telemetry series where we will try to introduce a new framework that will allow us to give more insights on our SQL database. Today's episode we will be focused on how to collect data out of our SQL databases, and we will introduce the new framework named the SQL Commenter. If you enjoyed today's content, don't forget to like and subscribe to the channel. This episode will cover a lot of things. That is the reason why it's been split into two distinct parts. Part 1, which is today's episode, we will explain the technology, the SQL Commenter. Part 2, we'll be delivering a technical tutorial on how to use the SQL Commenter. So let's see what you're going to learn out of this episode, the part 1 of the SQL Commenter. So first we'll do an introduction to give you the context. Then we will jump into how we can observe our SQL databases. And then we will present the new framework named the SQL Commenter. So the introduction. Many enterprise applications are relying on SQL database. So it could be MySQL, Postgre, MariaDB, Microsoft SQL, Oracle, and more. So if you look at the well-known enterprise solutions of the market that are heavily used by our financial services, insurance companies, banking, and more, most of those solutions allow us to fully customize the application by defining either what we would like to display within the screens, the workflow related to creating or validating the data, our assets. But usually all those customizations are at the end big blob that we store on our SQL database. As a consequence, the database is used to retrieve the data and drive how to visualize the data, what type of workflow we need to execute. In fact, most of the performance engineers will confirm that most of the biggest problems related to performance on those platforms is the database. Database was the #1 source of issues on those critical applications that help us to drive business, finance, and more. So the big question is, we know that database is sensitive related to our business. So how can we properly measure our SQL database? So how to observe your SQL database? So let's see the various tools. So the first one I would like to present is dbMarlin. So you can check here, you got a URL to check out the website. dbMarlin supports various SQL databases from MySQL to Oracle. It will provide you a lot of insights and a lot of statistics related to what's going on in your database. The next one is MySupermon. You can check their website here. And MySupermon is quite similar to dbMarlin, except it also supports MongoDB. MySupermon has a pretty cool feature related to testing. So if you execute any type of tests, you can start a recording and stop a recording on MySupermon, and MySupermon will collect even more statistics and more insights on what's going on during your tests. So if you want to understand why your test has failed, then MySupermon will give you the right details to understand if it's related to your database. Of course, there is also tools that are pretty much specific to one of the database engine of the market. And one of the one I'd like to refer is DSite software. So DSite software is highly specialized in Oracle. It gives you a lot of details on what's going on in your database, Oracle database, and it has a pretty cool feature. It's a replay, so you can replay an event happened previously in your environment, and by replaying you will understand what was the consequence or what was the root cause of your problem. Of course, all the databases of market has also their own tooling. So if you look at Oracle, Oracle has their own tool sets, and Microsoft SQL Server has also a pretty awesome tool called the MySQL Profiler. Usually, if you have to understand what's going on and get the execution plan, you use that tool to get more details. And the last one I'd like to refer to present is SolarWinds Database Performance Analyzer. Check out the websites to get more details as well. In reality, all of those solutions are collecting metrics using the internal technical database to retrieve their own metrics. So within your database, usually they're either technical administration tables, or it could also be technical views. In those views in your database, you can usually get the number of queries, the number of connections, the number of bytes, anything related to full scans, the number of reads, number of writes, and so on and so forth. So those KPI are very interesting, but if your response times just increase significantly, it would be very difficult to understand what is causing this from your database perspective. So this is what we call usually black box monitoring. So every SQL database engine has technical views, like explained before, that will provide those statistics, events related to the database. The commercial tools of the market, they are simply relying on the monitoring statistics available in those views. So they are technically querying statistics from those technical tables. So let's take the example with PostgreSQL. Let's say I want to report health metrics and statistics on how my SQL database is behaving. So to do that, we can take two different angles. The first angle is we can collect operating systems metrics on the PostgreSQL process running in that environment. So we can collect statistics like the CPU usage, the network, the disk I/O activities, the number of bytes, read, write, number of byte exchange, number of connections, all of that type of details. You can also collect, of course, statistics more on the database side, but usually keep in mind that it adds overhead to the SQL engine. So if you want to collect statistics, look at the documentation of your database, because you would probably have to enable some options on your database to get those statistics. So in the case of PostgreSQL, in the configuration of Postgre, there are several components to enable to get more insights. First, you have track activities to monitor the command executed, track counts to collect stats about table, index, access, and more, track functions to keep track on the usage of user-defined functions, track I/O timing to monitor block reads and writes times, track val I/O timing to monitor the valve write times. So once enabled, technically there is like a process, we can name it collector, that will run and collect statistics and then expose the statistics in a database view. So it means that every X seconds, Postgre is collecting data, it aggregates and exposes the statistics in those views. So most of the SQL engines proceed with the same process. It usually doesn't give you live insights, but more like aggregated live insights related to those statistics. It is usually done that way to reduce as much as possible the overrate of collecting statistics on a database engine. So once you have enabled those modules, then those views will be populated. So which means we can run some queries to get some statistics. So for example, if I want to report the cache hit ratio on the PostgreSQL database, I can do it by running a command related to that view. So here is the query. The query obviously is calculating a ratio like expected, and it's collecting statistics from the database view called pgstat database. So this is a technical view from Postgre. We can do the same if I want to collect, for example, the number of the commit ratio that happened on my PostgreSQL database. I can do another type of query. Here it is. And you can see here it's doing the same query, not the same query, but it's running a query against the same view, pgstat database. So now let's have a look at the Prometheus exporters, because most of the database engines of the market has Prometheus exporters. So if you stay in the PostgreSQL topic example, obviously PostgreSQL has a Prometheus exporter called the Postgre exporter. So the PostgreSQL exporter will collect metrics from your database by running some queries against those technical views. So you can either use the default queries to collect the default metrics, but what is pretty nice is that you can also add your own queries to extend more or add more metrics to the exporter. This is a great news. There's another interesting Prometheus exporter. It's provided by Percona. It's pgstat monitor. So it's basically collects statistics related to your database. It's really interesting, this project, because it will provide the important queries that has been running on your system. So it will basically return some buckets with the counting the most important numbers of queries that happens in your environment. So if you combine both exporters, it will be quite interesting, because you will have in one end more, I would say, general statistics on your engine, and the other way will show you the most heavily used queries that happened on your SQL database. So you can combine both of them. Usually, when we think that we have an issue related to our database, we use gently our DBA to look at it, to detect issues related to missing index, missing table statistics, or anything related. So basically at the end, what they do, they take the query that seems the problem, rerun it, get the execution plan, get more insights, and make a decision out of that. This is the reason why DBA are usually using very specialized tooling to understand what is slowing down a given query, or what are the most important queries generated by our application. So usually DBA are using solutions that will show not only the health metrics, but also events, queries, execution plans. And so the problem is that at the moment, if we need to troubleshoot, we are not efficient enough. We detect the problem, then we go and see our DBA to get more insights. So basically we have to wait until they analyze to get the problem. So in observability, we are pretty much now used to take advantage of traces to understand where we are spending time in our architecture. So when it comes to database in tracing, well, at the moment, we only know that, let's say we're spending, 100 milliseconds in the database, but we don't know if those 100 milliseconds were mostly in the network, or in a full scan, or related to, I don't know, a missing index. We don't have those details. So because of the lack of details, we have to rely on our DBA. So if we see that the traces takes a significant time in the database, then we ask the DBA to look at it. So we don't have the answer right now on what's slowing down our query in the database from a trace perspective. So what would be just amazing, I think, for us is to have that missing details in our traces, to include what is currently happening in our database. That would be just amazing. Well, there is a good news. There is a fresh new technology that has been provided by Google that will help us to achieve that. And the technology is simply named the SQL Commenter. So let's have a look at the SQL Commenter. The SQL Commenter is a suite of plugins that will add context into our SQL query. The context is technically added with the help of SQL comments, containing information about the code that has been requested for that query, the framework, and more. The augmented SQL is adding key value pairs as SQL comments on our queries. So if we take an example, let's say I want to insert questions into a table called poll questions. Here is the SQL statement that will be sent to our database to insert those questions. Now, if we run the same query, so what will happen is from the moment you use SQL Commenter, there will be a wrapper that will add extra information to our queries. So now if you look at the same query now, send it by the wrapper, you can see that we have the same statement, but at the end of the statement, we can clearly see some SQL comments. And if you look at the structure of that comment, you can clearly see a couple of key value pairs. So you have the controller, the DB driver, the framework, and also information related to traces. So trace parent and trace state. The plugin attached to our preferred coding language will add several fields like the controller, the DB driver, the framework, the route, and all the details related to open telemetry. So the trace parent, which is the W3 trace context trace parent, the trace state, which is the W3C trace context trace states, and so on. The SQL Commenter currently supports the following SQL engines. So MySQL, MariaDB, SQLite, and PostgreSQL. And of course, everything running in Google Cloud SQL, because Google Cloud SQL supports, at the end of the day, those engines. By default, SQL Commenter will generate logs with the augmented SQL context in our database engine. So, which means if you use any agent log collector and forwarder, you would be able to collect those logs from a database engine and attach it to any application you need. What is the valuable output of the SQL Commenter? Well, in fact, the value at the moment is when we're using it in combination with Google Cloud SQL. Google Cloud SQL will automatically add more details to the execution of a query. You can see the index, the full scan, the execution plans, and more. The other advantage is that Google Cloud SQL would generate Google Cloud traces with all the steps, starting from the user to the database. And when we are in the database, we have exactly the level of details that we were looking for. All the steps that was required to execute the query inside our database. This is great. This is what we're looking for. So what about using vanilla version of those SQL engines, like PostgreSQL, for example? Well, at the moment, we don't have the same value. And I think it's just a matter of time. Google has technically enhanced the version of their supported SQL engines to add extra libraries that will generate those traces. Which means if the main contributors of the various SQL databases engine implements those changes by adding those new libraries, it will mean that we will be able to get traces with this help of SQL Commenter. So we will have traces with all the actions that we're looking for, in our on-premise databases, but also in any fully managed SQL database. In terms of coding language, the SQL Commenter supports various frameworks and language. So here is the list of framework per language. So if we start with Python, the SQL Commenter supports Django, PsyCop2, SQL Alchemy, and Flask. For Java, it's going to be Hibernate and the Spring Framework. For Node.js, it will be Knex, Express, and SQLite. And last, for Ruby, it will be Rails. In order to get more details on this technology, I would like to call one of the main experts related to SQL Commenter, and I'm referring to Jan Kleinert from Google. So let's call her. Hi Jan, how are you?
Hi there, thank you. I'm doing great, how are you doing?
Very good, thanks. I'm so excited that you are taking the call today because we're doing a dedicated episode on the SQL Commenter. And we would like to get, obviously, more details and more insights related to this new awesome framework. So before we start, could you briefly introduce yourself to the community?
Sure. So I'm Jan Kleinert. I am a developer advocacy manager at Google, part of Google Cloud. And my team focuses on compute, so things like VMs, and also databases. And that's kind of where this SQL Commenter came into my world. So, my background is, a mix of developer advocacy, software engineering, and then web analytics and optimization. So kind of all over the place.
I'm very interested in Cloud SQL, and especially when we use it with the SQL Commenter. To prepare this episode, I had to play around with the technology, and I was able to see that SQL Commenter supports a couple of database engines of the market, like the MySQL, MariaDB, PostgreSQL, and others. Is there any plans to support all the databases? Most of the big ERP or enterprise platform usually rely on Oracle or Microsoft SQL Server. So I was wondering if there were any plan to support also those enterprise databases.
Yeah, that's a great question. So when we're talking about SQL Commenter, it's an open standard and it's also a library. And the team, as they were creating it, they tested it against Postgres, MySQL, MariaDB. But now that it's out there, we are getting feedback from users that they'd like to see the support against more databases as well as more frameworks and ORMs. Because the standard, the algorithm for implementing it is out there, it's totally possible that we could get the support for other databases like Oracle or MySQL as well. And we're hoping that we can get some contributions from the community to help get some of that additional support in there. So I don't know that we have any specific timelines on support for those, but it's certainly a possibility, and we'd love to see and hear from folks so we can figure out the priorities on all of those as well.
Makes sense. I really love the ability to add in our current traces the spans with all the detailed steps and operation that has happened in our database. I know that currently the SQL Commenter is only being able to generate traces when we combine it with Google Cloud SQL. Are there any plans to provide this tracing feature on vanilla versions of database engines?
Yeah, so if I'm understanding correctly, I think you're referring to how, SQL Commenter can insert like the trace state, trace parent, all of that into the comments. And then in Cloud SQL, the team has done some work to tie that into the Cloud SQL Insights interface, right? So that when you go in there and look at something, you can actually go in and then jump into traces or look at query plans and all of that. Right now, you're right. Cloud SQL is the only database I'm aware of that is actually integrated against that information that's coming through in SQL Commenter. And we're not aware at the moment of any ongoing work with any of the other database providers, but we would certainly love to have that. So other database engines, as we're able to reach out and see if they're interested in integrating that and implementing it, I know that folks on our team would love to work with them to get that done. If there's folks out there who are willing to get that work started.
So I guess it's the perfect time to make a call to the community. Big call, big announcement. It's time to contribute. We need to be sure that anyone can take benefit of this awesome framework on-prem or in any cloud provider. Speaking about the future, you just mentioned that Google gave back the SQL Commenter to the OpenTelemetry community. Do you know if there is any roadmap, any plans for the future to add extra features within this framework?
Yeah, I think we're hoping that now that this is, part of OpenTelemetry, and we're hoping we can reach a broader audience and get more of those contributions and interest from the community going. I think, in the shorter term, we're looking to expand SQL Commenter support for more languages and ORMs, specifically PHP and Go. I know are two of the areas that are being looked into first. There's been quite a bit of feedback that those ones are ones that people would like to have support for. But just looking at the issue tracker, I've seen that there's some desire around other languages and frameworks as well. So we're hoping to get some contributions there, get people to help us out and get more support.
So if I understand you very well, we need to make another call to the contributors of the database engines to convince them to include the tracing library, or I would say the capacity of generating traces. Maybe it would also great to also ask the community to include the .NET support. There are still a lot of enterprise platforms that are built using .NET, so it would be also very useful for us to get this .NET support. SQL databases are very popular and heavily used in many solutions, but now if we start a new project, we try to utilize more NoSQL database. So NoSQL database has few observability solutions. So we are clearly lacking of details when it comes to collect information and more insights on what's going on those NoSQL database. Are there any plans to also support non-SQL database, like the non-SQL commenters, sort of?
Yeah, great question. So unfortunately, we don't have any plans currently, but it does seem that the SQL Commenter standard could be potentially extended to work with NoSQL databases. I suppose the naming will always be strange if it's SQL Commenter, but with the algorithm that's out there and the specification, like it could be extended or adapted to potentially work with those, even though it would be slightly, different in the way that it would have to be.
By preparing the episode, I have looked at the various ways of observing SQL databases. By looking at the native technology provided by the SQL engines to collect metrics and statistics from the database, the commercial toolings, and the Prometheus exporter. The SQL Commenter is clearly changing the observability game on our databases. For now, we rely at the moment on metrics that are exposed by the database engine through the technical views. I was wondering if there was a plan to also include some metrics with the SQL Commenter. OpenTelemetry, as you already know, supports traces, logs, and metrics. Maybe it could be great to add the metric dimension in the SQL Commenter. That could help us to bring more value to our various projects.
That's an interesting thought. So a couple of things related to that. So with SQL Commenter, there's the kind of standard fields that are always supported. So things like DB driver, obviously the OpenTelemetry trace parameters, framework, action controller route, all of that. But you can include any custom tags and values as well. So key value pairs that you come up with yourself. So this isn't exactly answering your question, but I promise I'm going to get there. So you could include, if you wanted to do testing, let's say you had two versions of an application and you wanted to test version 1 and version 2, to see if there was any sort of, performance issues. You could do an application tag where, depending on the application version, it could be 1 or the value could be 2, and you could pass that through SQL Commenter as well. So any of these arbitrary key value pairs will work, and as long as whatever you're using on the other side to, decode that information is looking for any sets of tags, then you can get that information back. For example, if you're pulling this into an APM tool or something like that. And it's also going to be there in whatever logs you're looking at. So you can add arbitrary tags for kind of whatever values you want. With regards to specifically like database metrics, that I'm honestly not sure if it would be easy to insert that from your application, right? So it seems like it would be kind of a chicken and egg kind of situation. The timing of when you're inserting the comments wouldn't probably be right. But if you've got, metrics, various metrics, add-ons, plugins, whatever enabled on your databases, that's typically coming out into the logs anyway. So if you're pulling logs, the SQL Commenter logs and the metrics in your logs, potentially there's a way you could at least view all that information at the same time. But I don't know of a way right now to like insert metrics related information into the SQL Commenter comments.
Yeah, because when we're using profiling tools or DBA tools, we can get the details related to the execution plan, of course, but usually we get by default the number of records that has been involved in that query, the read, the write, the response times related to the query. So I think it would be very useful to also add more details in SQL Commenter. For example, if I run a particular query that has been executed, it would be great to add the metrics like say the execution time, how many records were involved when executing that query. Yeah,
that's a great idea. I think if you can raise that in the issue tracker as a feature request, if it's not already there, it might be. That would be a great one for the team to look at, because I can see it sounds like there would be a lot of value and benefit from something like that.
Just by curiosity, behind every project or framework that we are providing to the market, there's always a story. Let's say I had that situation, or we were running on biggest issues, or we had a lot of pain, and then someone come up to an awesome, brilliant idea that resolved those biggest constraints. Is there a story behind the SQL Commenter? So why did Google decide to work on such a framework and provide it to the community?
What I do know is that it's something that the team, particularly the team that was involved with Cloud SQL, had been wanting to implement for a long time. And just the ability to give users who might not be database experts the ability to kind of visually see what's happening and visually understand performance. And, for full stack developers and folks out there who are now, responsible for understanding database performance and how it interacts with your application, when you're using an ORM, that's so hard, right? Like it's really difficult to know, unless you're intimately familiar with the application, what requests are resulting in these queries that might be problematic. So being able to provide something that makes that easier for people without requiring them to be super database experts was one of the goals behind the project, and something that I know they had wanted to do for quite some time. So it's really exciting to see it out there. And in my opinion, even more exciting to see it out there, donated to the community so that we can do this in a vendor neutral way and expand it.
It would be great to have like a switch that you can turn on or turn off to get all the traces for all your queries. And I'm thinking about CI/CD process where we have unit tests, functional testing, load testing, and more. It would be great that for each test that we have executed, we have all the traces with the user, the code, and the database steps. I think it will help us to save a lot of time when we are saying that the problem is related to the database.
Yeah, I like that idea as well, to be able to do that with some kind of flag. at the risk of sounding like a broken record, that one would be great to get in the issue tracker as well. I feel like the more of these that we get in there, then we can get feedback from others on, yeah, that'd be really helpful for me too. Or, oh, also, I'd like to have this as part of that as well. So, yeah, I'll keep an eye out. I'd love to see that in there as well.
Okay, so I will add my suggestions to the community. And also I recommend for all the community listening for today's episode to submit your suggestions. So here is the link. So if you have any ideas or any feature requests, I will recommend to look at it. And you can also follow the latest features, the latest news related to the SQL Commenter. One thing that I was wondering, if Google has a process to use SQL Commenter to detect regressions. In Observability Backend, you can search for traces and try to compare them. So you mentioned that we could potentially add new key value pairs like the version number of our application. So we're thinking that it would be great to find a way to search for the traces of a given version and do the same for another version and compare it. Let's say we have version A, we get the traces, we get the version B, we get the traces, and then we compare it to figure out if we have improved, or in the other way, we have introduced regression. Do you have any recommendation for the community on how to achieve this type of trace comparison?
Yeah, so the way that I've been doing it thus far is fairly basic probably, but in a tool like in the logging or tracing views, I'm just using whatever queries I've got available. And once you see what the syntax is for how the comments are structured, I'll just set up a regex or a query that's looking for whichever tags I'm caring about and kind of just view the separate logs that way. I haven't personally done anything where I'm then aggregating that to try to do any real analysis. And that's partly because I'm lucky and have most of the time I'm working in Cloud SQL, and Cloud SQL Insights is doing some of that work. So when you look at the interface, you can drill in based on certain, values or aggregated sets of information and see it that way. But it should be possible if you've got a particular, set of queries that you want to look at and they're tagged in a certain way, you should be able to, narrow down those entries in your logs and do some analysis that way. But it would require work on the part of the individual who's trying to do this analysis at this point to figure out how to put that together.
I think we could basically try to launch a challenge here. Maybe trying to find the right log stream pipeline using Flintbit or Flintd that will allow us to ingest the logs coming from the SQL Commenter, of course add the useful tags and then store it, so then we could attach it to a context and search for them. So I will try to work on this on my own to find if I have the right solution, and I will share it if I come to the right solution. But if anyone of the community has found the solution for that, please drop your comments, and I would love to do an episode with you guys to explain and share that process to everyone. All right, I think I covered most of the questions that I had. Of course, if any one of us has questions, you can drop the questions to YouTube or Twitter, and I will forward back to Jan so she could answer it, and I will update the answers on the comments. So thank you for your time. Thanks for Google for dropping this great technology for the community.
Thank you.
Thank you so much. See you soon. Maybe I will probably have more questions. See you. Bye.
Thanks. It's great to be here.
So that's it for today's episode, the part 1 on the SQL Commenter. So we covered a lot of things. So you saw how to observe your current SQL databases, the various commercial tools available, the various Prometheus exporters, and of course we did this introduction to the SQL Commenter, and then we did the interview with Jan Kleinert to get more insights on the SQL Commenter framework. So if you enjoyed today's episode, don't forget to like and subscribe to the channel. We will produce more content. And if you're looking for the tutorials, don't forget to look at the part 2 that will go deep in how to utilize the SQL Commenter. All right, see you soon for another episode.